Hi guys, so as promised, here's a lesson on completing the square. We talked about this in the team session yesterday, but I know that a few of you were still a little bit stuck, so let's just have a lesson on this. So let's just remind ourselves of how we squared brackets. So if we have just a look at this example here, on one side of the grid, I've got x plus 3, and on the other side of the grid here, we also have x plus 3. So because it's the same thing multiplied by itself, then this is going to be the same as x plus 3 all squared. Just remember what I said before in the session, that this sign here just means that it's equivalent to it. So for all values of x, this will be the same as this. So I could write it just like that there. So let's just remind ourselves, obviously this one therefore could be written as x plus 4 squared. And then this one could be written as x plus 5 squared as well. Remember that it doesn't just always have to be positive. This could be, say, for example, a negative 5 here, and then it would be x minus 5 all squared, and it would still be exactly the same thing, okay? So if I were to expand these brackets, you could see that I have x squared plus 3x plus 3x, and then 3 times 3 gives me 9. So altogether, I'd have x squared, and then 3x add 3x gives me 6x, and then plus 9. On this one, x squared plus 4x plus 16. So altogether that would be x squared plus 4x, which is 8x, plus 16. And then on this one, let's pretend that it's minus 5 and not 5, okay? So we can see the same thing. So it's x squared minus 5x, and then minus 5 times minus 5 would give me a positive 25. Just remember that if you square a negative number, or if you times a negative by a negative, it's going to give you a positive answer. So that will be x squared minus 5x minus another 5x is going to give me minus 10x, and then plus 25. So you can see that in all of these, if it's a square, you can see that the last term is always going to be positive, whether this is positive and this is positive, or whether they're both negative, because a positive times a positive is going to be positive, and a negative times a negative is going to be positive as well. So regardless of whether you're squaring a negative number or a positive number, that's always going to be positive there. So what we could say is that we can notice that because you're going to have two lots of 3x was doubled to give you 6x, or because you've got two lots of 4x is doubled to give you 8x there. And because you've got two lots of minus 5x, that's doubled to give you minus 10x. So you could say that what happens when you square the bracket is that you're going to have two lots of whatever the number is, so that amount of x, and then you add b squared there. Don't worry too much about that at the end. Remember, the b squared just comes from 3 times 3 here gave me 9, which is 3 squared. 4 times 4 gave me 16, which is 4 squared. And minus 5 times minus 5 gave me 25, which is minus 5 squared. So that's where that just comes from there. That's just a quick reminder, but I'm pretty sure that we're all okay with that on this slide anyway. Okay, so if we have a look then at the one that we were talking about a moment ago, so if we had x plus 3 all squared, it can be written in this diagram here. Now let's say, for example, I wanted to get rid of this 9, so I'm taking away that 9 there, which means I'm left with this diagram here. So therefore, I still have my x squared, I still have the 3x here, and I still have the 3x here. So altogether now, I've got x squared plus 6x. So the 6x comes from the 3x, add the 3x. Another way to write that is because all of it altogether is x plus 3 all squared, I've taken 9 away from that. So I could have written that as x plus 3 all squared, and then I take away the 9 and I get that there. So, and then you could also think about this as, well, what I could do is take this 3x here, move it around and add it on at the bottom there. So therefore it becomes 6, just like this diagram here. So all that's happened there is I've moved this 3x around to the bottom. So now the 3 and the 3 have added up here to make 6. So that would be x squared plus 6x. So these two diagrams on the right are exactly the same thing. So both of them show x squared plus 6x. And we can see because it's the same as the first diagram, to get to the second diagram, take away the 9, then I can also write that as x plus 3 all squared, take away 9. And that's the process that we're going to have a look at today, taking something such as this and writing it in this form here. There are many reasons that we might want to do this. For the purposes of next lesson, it's quite useful because rather than have an expression with two x's in, so that x in the x squared and the x in the 6x, I now have an expression with just one x there. So it's just x added to 3, and then all squared, and then minus 9, rather than adding another lot of x or something else happening there. So we will sometimes find it more useful to have it written in the second form, and other times, of course, we might have it more useful in the first form, but we're just going to learn how to go between the two of them. We could also do something similar on this one here. So I'll just do this a little bit quicker. So from this to go to this, well, the 16 has gone missing. So I've taken away the 16 that was there. So that 16 has now gone. So this will just be x squared plus 8x. I'll just rub that out because obviously it's not gone from that one there. And then obviously because these two things here are the same, I've just taken 16 away from what I had there. So another way of writing that would be just to write it like this here. And then, of course, we can rearrange that if we want to. We can move that 4x that's here, move it around to the bottom there, and it will add together to give us the 8x there. So that will be x squared plus 8x, which, of course, we can see, because we've just moved it around, we've not changed it anyway, we've not made it any the area any different. It's just that we've reorganized it, we've rearranged it. So that will be the same as x plus 4 all squared minus 16. So that's all that we've got to do. Okay, so what we're going to focus on now is going backwards. So let's say, for example, here I've got x squared, and this would be 20x. So x times 20 gives me the 20x. So that could have been written as x squared plus 20x. So we want to get into a square. We want to make it become a square. So obviously at the moment it's not a square because this side is x long and this side is x plus 20 long. So because this side is longer, well, both sides have x in common. It's this part that's different. So for this part here, if I want both sides to be the same, I need to chop it in half there, just like that. So now this side is just going to be x plus 10. And then if I chopped it in half and I moved it around here, then this side will now be 10. And obviously this is still x here. So now I've got x squared, plus 10x, plus 10x. And then these two things now at this moment are the same, okay. So if I wanted to, I could try to write this as a square with both sides being x plus 10. So if I wanted to, I could square it there, and that would give me the area of the whole thing here. The problem is, of course, that the difference between the whole square and that before is that I've got this little part here included that wasn't there. So I'm going to need to take that away if I'm going to say that they're the same. So the area of that missing part would be 10 times 10, or 10 squared, which is 100. So therefore, if I want these two to be the same, I need to get rid of that 100. So I'm going to subtract the 100 there. And that's all that's happening. We'll just do one more example of it. So let's do it on this one here. So we've got x squared plus 16x, and obviously x times x is x squared, x times 16 just gives you 16x there. So I could write that as x squared plus 16x. Then if I want to make that into a square, then obviously we know that the x is the same on both sides, but the 16 is different, so I need to halve the 16, and move half of it up to the top so that they're both the same. So the 16 was halved, so that is now 8 long, and the other 8 has just gone up to the top, up there. So that's still x, and that's still x. So you can see that will be x squared, that will be 8x, that will be 8x. And these two, or the yellow and the green sections, all together are the same thing. If we wanted to say, for example, that we want to write an expression for the whole square, so to find the area of a square, we know that we can just do square the sides, so x plus 8 all squared. But we need to then take away this little bit here that is in the square that's not in the rectangle to the right. So that would be, no, wouldn't it? It would be 64. So 8 times 8 is 64. So if we want these to both be the same, then I need to take away that 64 because it's in the square, but it's not in the rectangle. So I want them to become the same afterwards. And if you really wanted to double check it, I could actually expand what I have here. So x plus 8 all squared. If I expanded that, x times x is x squared, x times 8 is 8x, x times 8 again will be 8x, and 8 times 8 is 64. So altogether that would be x squared plus 16x plus 64. But then obviously on this one I just had the x squared plus the 16x. So that's why I'm taking away the 64 there. So I need to get rid of that 64 there. So each stage I should have written the minus 64 there. You get that will cancel out there. So you're just left with the x squared plus 16x. So if we look at these examples here, then what we can see is happening is if I just focus on the first two terms, I've got the 6x was halved, so that gave me a 3. So it's x plus 3 was the side of the square. That's being squared. And then the bit being missing there would be 3 times 3, which would be 9. So I take away the 9 there. On this one, we had x squared plus 8x. So we wanted to make that into a square. So the side of the square would be x plus 4 for each side. And then obviously if we want the area of the square, I'd have to square that. But then I'm taking away 16 because that's going to be the little bit of the square that's left over. Similarly for x squared plus 10x, we've got x plus 5 will now be the side of the square. And then I need to get rid of that 25 there, okay? So one way of thinking of this would be to have, if you've got x squared plus something x, you halve that something, and then that will be squared for the side of the square. And then you take away whatever this was squared. So b minus 2 all squared. So that's all we've got to do there. Or do that. That might seem a little bit complicated. Let's just do that with a few examples. So if we have a look at these, all that we need to do for each one is make it into a square. So it was x and 10 on one side, but we want it to be the same on both sides. So it's going to be x plus 5. Square that to get the area of the square. But then we'll have 5 times 5, that little part of the square there that we need to get rid of, so we subtract 25. Similarly on the next one, all we've got to do is halve the 12 to get the side of the square there, so x plus 6 all squared, and then we take away that little bit that's missing, which is 36 there. We can do the same on this one here. So we've got x plus 1 all squared, and then we subtract the 1. Doesn't matter if it's negative. Half of minus 6 is minus 3. We square that to get the area of the square. And then remember, we take away the bit that's missing. The bit that's missing is going to be minus 3 times minus 3. So that's going to be a positive 9. So I need to take that away. So I need to take away 9. So once you do this step, it will always be positive on the end. Okay. When we get to next lesson, there might be, a little bit later on, there might be some times where there might have been an extra term on the end. So for example, I might have added, say, 26 here. And if I'd have added 26 here, you can see that the minus 25 add the 26 is then going to become positive. So, but when you do the first step, this part is always going to be negative. So it's always going to be negative there when you complete the square, but then you might collect like terms, it might become positive afterwards. So let's just do another one there. So x minus 4 all squared, and then minus, I keep doing that, minus 64. Okay, so on the last two, just leave those just for the moment, but you might want to have a go at these two. I'll just pause it for a second, and then you should pause it too, and just have a go at 6, 7, and 8 there. Okay, so if I quickly go through those then, you've got x plus 12 all squared, and then minus 144. On this one, half of 30 is 15, and then we square that, and then 15 squared is 225, so then I take that away. On this one, I've got x plus 50 all squared, and then I subtract 50 squared, which is 2,500. It doesn't really matter about the numbers. That's all that we've got to do. Okay, I'm just going to do a couple of examples where we've got another term on the answer. So far, we've only looked at where we've got an x squared term and an x term, but we may have a constant term on the end, which is just a number on the end. So in question 1, the constant term is +9. On question 2, the constant term is +27. And on question 3, the constant term is just -9. Okay. The reason we call it constant is just the value of that will always stay the same. Okay. Whereas the value for x is going to change. So sometimes x might be 0 or 1 or 2. So these are what we would call variables. So they're going to change. So constant just means it's just staying the same. Okay. So it's just a number there that always has the same value. So if we look at the first one, we've got x squared minus 10x plus 9. When we were completing the square, all we were doing was focusing on the first two terms. So that's exactly what we're going to do now. We're just going to ignore the constant term on the end. So we halved the 10 to get 5. So the side of the square would be x minus 5. And then to find the area of the square, obviously we square that. But we take away the bit that's missing, which is going to be the minus 5 times minus 5, which is 25. So we take away 25. So that part there is just exactly equivalent to that part there. So these two are both the same. Then, of course, we still have that +9, so I can't completely ignore it. So that +9 is still there. So I'm still going to involve it. So I've still got that +9 there. So all I can do then is I can collect that. So minus 25 add 9 is going to give me minus 16. So that's all I can do there. So that's just going to be my answer. Okay, so let's just put question 1 there. Let's do another one on question 2. So we had x squared minus 12x plus 27. Again, I'm just going to ignore the constant term, just focus on this part for the time being. So the side of the square would be x minus 6. Then obviously I square that to find the area. Then I take away 36. And then I still have the plus 27, so I've still got that on the end there. So I've still just taken that on, okay? So when I complete the square, the two bits underlined there are equivalent, so that's the same thing. But then obviously I've still got the plus 27 at the end. Then I can collect together the like terms. So minus 36 adds 27. I could then collect, so that's going to give me minus 9 there. Okay, you might want to pause it for a moment and just have a quick go at question 3. I'll just go through it now. So we have, oops, let's just write it out in full. X squared minus 8x minus 9. So if we find the side of the square, that's going to be x minus 4, all squared. And then the little bit that's missing there is going to be minus 16. And then we've got to subtract the 9 there as well. So if I tidy that up a little bit, it's just going to be x minus 4, all squared. Minus 16, subtract another 9, is just going to give me minus 25. And that's all we need to do. So for this lesson, we can just stop there. If you have any questions at all, then obviously just ask me on Show My Homework or via email, and then hopefully I can get back to you quite soon, and hopefully we can remember this from earlier on in the year. Have a good day, guys. See you later. Bye-bye.